Hello and welcome to this edition of our AWS podcast series, Innovation Ambassadors. I'm Sara Armstrong, and as Senior Manager for Worldwide Prototyping at AWS, along with my AWS co-hosts from around the world, we'll act as your ambassadors to some of the most interesting engagements with our AWS Solutions Architecture prototyping teams. Every episode, we provide you with a roadmap to innovation in technology solutions. We're so glad you joined us on this journey. In this episode of Innovation Ambassadors, we're showcasing the journey of ICI, a manufacturer of infrared cameras and software that provide continuous monitoring of thermal data to provide valuable insights in manufacturing and other industrial applications. We'll learn about ICI's collaboration with the AWS Prototyping team and their efforts to cost optimize their video streaming, reduce latency, and enhance resiliency across their architecture. Well, I'm excited to welcome from ICI, Jeff Guida, Chief Innovation Officer. Thanks for being with us, Jeff.
Hi, Sarah. Thanks so much for having myself and our team here.
And also from ICI, we have Abhishek Madaan, Senior Software Engineer. Welcome, AB.
Thank you, Sarah. It's great to be here.
And from our AWS Prototyping team, we have Ozan Cihangir, IoT Prototyping Engineer. Ozan, always great to talk to you.
Thanks, Sarah. It's my pleasure to be here.
Well, Jeff, for our international audience, can you tell us a little bit about ICI?
Absolutely, Sarah. So ICI, Infrared Cameras, Inc., is an infrared camera manufacturer. We build both hardware devices and software for infrared cameras and their uses. And just for the audiences who are not familiar with infrared cameras are cameras that see heat. So they see a different bandwidth of the electromagnetic spectrum that allows them to measure temperature for every pixel in their field of view. So tremendously powerful devices. Infrared cameras originally came out of the military. They were extremely expensive. They only began being used in the commercial world, the civilian world, a few decades ago, but they were always tremendously expensive, $50,000 to $100,000 devices. As a result, their use cases or applications were pretty limited. They had to be operated by a trained thermographer who would hand inspect things on an intermittent basis. But what's happened there is that in the past decade or so, cost curve has been coming down, but it's really accelerated in the past 10 years, such that prices of infrared cameras are now down 90 or 95%. And this opens up a whole new realm of use cases where you can now afford to forego the thermographer and instead mount an infrared camera on a pole pointing at an asset and use it for 24/7 continuous monitoring. And this utterly transforms how you can use these insights from temperature data in manufacturing processes and all sorts of industrial applications and beyond. And what we've built at ICI is really the world's first infrared camera cloud that really turbocharges that insight, such that a customer who has hundreds of cameras monitoring hundreds of assets at facilities around the world can monitor temperatures of key critical components, can be alerted when temperatures go out of spec, can respond to those alerts, generate work orders, build things into their corporate infrastructure, and manage that data and improve their operations, their reliability, their safety, and their performance.
So AB, talk to us a little bit about this infrared camera cloud, a little bit of the architecture that you had already built.
So the cloud architecture works with our edge application called IR Flash Pro. The IR Flash Pro are software that it takes a radiometric data from our cameras and converts them to H.264 and stream to our cloud architecture using a KVS pipeline. On top of that, it also sends temperature data, alerts, device information, all that using the AWS IoT Core SDK, using MQTT and to the cloud as well.
Fantastic. And Jeff, how did you come to work with Ozan and the team?
As you might expect, we spent a lot of time developing this new application, building out the architecture and the pipelines to leverage AWS's toolkits as much as possible. When we got closer towards the finish line, we started to suspect that we might have not fully understood AWS's pricing as it pertained to data egress. And this was something that was a little bit murkily documented on the website, and none of our engineers actually grasped exactly how this worked. And when we got down to the truth of it all, we realized that any time a viewer would view live streaming video from any of the cameras on their network, we would incur a data egress charge through the KVS pipeline through AWS's cloud. And this was something that would be a negative for our product because it would disincentivize customers from viewing their data. And what's the point of building a beautiful pane of glass where you can see 24 infrared cameras continuously if the customer can't afford to watch them? So we reached out to AWS. We said, look, this isn't going to work. We need help here. What can you do? either change the pricing or help us find a solution. And they were incredibly responsive. They said, look, we can help you work through this. We understand this is a challenge to your product's implementation and your product's success. We want it to be a success. We have our internal prototyping team that we suspect can help you optimize your architecture to reduce, if not avoid entirely, this data egress charge. And that's what we came to meet Ozan.
Ozan, take us from there. How did you work with Jeff, AB, and the team?
The main challenge was due to the specific use case of viewing multiple video streams from multiple viewers 24/7. And this introduced some egress costs, as Jeff explained, and we identified this early of the prototype in our workshops together with ICI team. And then we come up with this idea of using WebRTC protocol. WebRTC, in other words, Web Real-Time Communication. It is a peer-to-peer communication protocol which allows producers to stream video feeds directly to consumers instead of going through cloud. This obviously cut the egress cost because the video streams are happening from cameras directly to the viewers, to the web UI. And we started to implement this solution together with ICI team. We have implemented two sides of the application. One is the camera side and one is the web UI side.
And so, Jeff, you were able to measure the reduction in that cost given that new architecture. Is that right?
Yes, Sarah. It's actually quite transformative because when we're utilizing the WebRTC pipeline, we incur zero data egress charges. And it depends upon the position of the cameras and the users and the load and how many people are watching. But it looks like for the majority of the time, we can bypass the KVS AWS pipeline for live streaming and utilize WebRTC, which again takes the cost to zero. But on a net basis, we're probably reducing our total data egress charge by north of 70%, which is a tremendous outcome.
And AB, in addition to that cost reduction, we were also able to decrease the latency.
So since WebRTC is a peer-to-peer communication protocol, we were able to reduce our latency, which with our current architecture was around 6 seconds to less than 1 second.
So, Jeff, that latency really important for your end use applications, yes?
Indeed. The combination of the cost reduction and the latency reduction both really transformed the product solution. So on the latency side, obviously, latency is never a good thing when you're viewing something live and what you're seeing is stale data. For one example, some customers use our cameras to optimize production lines. And as product is coming off of a line, they're looking at the thermal profile of the finished product to ensure that glue has been melted, that various materials have reached the proper temperatures for the product to hit their quality targets. If you have a systems engineer who's located off-site, who is trying to optimize that production line and is looking at the data real time, and that real-time data is 6 or 7 or 8 seconds old, he's going to have a much harder time optimizing that production efficiency than if the data is within a second. And that's a huge improvement. Also on the kind of early fire detection application. So our cameras are used a lot to detect fire before you can see fire, because before something catches on fire and generates smoke or flames that are visible by smoke detectors or flame detectors, it gets hot. And as it gets hotter, you know that it's going to reach the burn point pretty soon. And so the sooner you know that, the sooner you can respond. While many of our fire detection systems have on-site, on-prem response architectures, whether it's fire suppression or simply line shutdown, some of our other clients have assets distributed in remote sites where they don't have on-prem response systems. And so the ability to know that there's a problem with a pump that may catch on fire or may just shut down imminently at a remote site and have that data be real time is tremendously powerful.
Now, Ozan, talk us through some of the resiliency that you were able to build into the application working with AP and the team.
The ICI cameras are going to be located in customer sites where ICI has little to no control in the network. Any disruption in the network would cause problems, especially during the live video streaming. These disruptions cause the cameras go offline for a long time. And as Amazon CTO Werner Vogel says, everything fails all the time, so we need to be prepared for this. So we come up with a resilient implementation in both camera side and the web UI side. In the camera side, we detect the network problems when they occur, and if there's any network disruption, then we just restart the camera pipeline. At the same time, in the web UI side, during the live video streaming, we try to detect the camera stream. If there is no camera view, if there is nothing changed in the camera, then we ask the producer to restart the application. So we provided a fully recoverable pipeline, camera pipeline in ICI's application. And we have tested the failure recovery feature for an extended period of time during the prototype.
Nice. And that resiliency, Jeff, so important for those remote locations.
For sure, for remote locations where bandwidth is constrained and connectivity is unreliable. But believe it or not, it's also important for non-remote locations because when you get into continuous 24/7 monitoring, at some point during that 24/7 week, you may have a network glitch. And when we have a customer, say a global logistics customer who's using our cameras to monitor hundreds of conveyor belt assets at hundreds of facilities globally, you can't have those cameras going down even once a week and not reconnecting because they're relying upon that pane of glass to look at all their conveyor belt architecture and see when a belt is overheating or a bearing is overheating or a motor is overheating because failures of those assets cost them tremendous amounts of money. And resiliency of our system is of paramount importance to prevent that from happening.
We often talk in this podcast about how experimentation and innovation, we often face challenges. And of course, this particular prototype was all about facing a broader challenge for your architecture, wasn't it, Jeff and AB? I'm wondering if there was something or observation or particular surprises that happened during the course of the prototype that you wanted to share, Ozan?
Actually, it was a very interesting coincidence. While we were working on this WebRTC implementation, there was a new feature. It is called as Amazon Kinesis WebRTC ingest feature. It was released as a preview. So we had a chance to try this, and it has a good potential to be used later on in ICI's application. At the same time, while ICI was testing it, we could get immediate feedback from them, and we could pull this feedback directly to the service team, and we could tell them, okay, this is needed from ICI, and can you look at it? And they put it to their pipeline. So this was an interesting surprise. And interestingly, this is not first time happening to me. During this 4 weeks prototype, for example, this happened. And before, it was the same for another service, location service. While I was working with a logistics company, we released location service as a preview. So it is always changing. It is very fast environment.
Yeah, the pace of innovation is just spectacular, isn't it? AB, tell us a little bit about where we are now. So Ozan and the team worked with you. You're able to reduce the latency, reduce the cost. What's the next step?
Once we're done with the prototype team, we engaged with the AWS account team, which is leading us towards a production environment to roll this prototype development to the production environment. And we have like a weekly meetings with them, so we stay in the right direction. And probably in 4 to 6 weeks, we will roll out this prototype development that we have done with the team to our production environment. And all our customers will be able to have that cost-effective solution and not able to get the egress cost associated with our previous architecture.
That's fantastic. And Jeff, as a bonus out of this whole engagement that we did with you all, your company shared an infrared camera demonstration platform for our new Santa Clara prototyping lab. So really appreciate that.
That's right, Sarah. And so, if anyone wants to see the results of our efforts and AWS's prototype team's efforts and how transformative all of this is to monitoring industrial assets, we've got a live demo at the Santa Clara prototype lab with a conveyor belt, a miniature conveyor belt with an infrared camera connected to our edge software and our cloud software. And you can see the entire solution working end to end.
Jeff, AB, Ozan, thank you so much for being here and sharing your story with us. And I would love to close with your reflections on the experience and what you might share with our listeners. I'll start with you, Ozan.
I have an industrial automation background, and I know how important it is to monitor the health of equipment. And it was very interesting to see this use case with ICI cameras. So you can point the camera to a field in your industrial environment, and it can detect this temperature changes and anomalies immediately. So this was quite mind-opening for me.
Fantastic. How about you, AB?
Yeah, from this engagement that we have with the prototype team, the best part that I got out of it is working with the subject matter expert, how much vast majority of development you can do in a rapid time. So we had this engagement for like 6 weeks, and I feel like we have done so much within those 6 weeks.
Jeff, final word for you.
I would say one of the key learnings for me, and this was a little surprising, is that When confronted with challenges, obviously it's always best to seek expert advice. And in this case, the expert advice was AWS. It's rare in my experience to have a vendor bend over backwards to reduce the amount of revenue they're going to get from their customer. AWS did exactly that by giving us their best and brightest team to help us circumvent this challenge we'd hit with data egress costs. And to AB's point, it's always amazing what you can accomplish when you have the very best, the brightest in an area of competency, and how much more progress can be made in a very short period of time. So we're stunned with how much they were able to transform our architecture and solve this problem. And I would encourage any developer who is facing a similar hurdle to reach out for expertise. Always more can be done with more people than when something is kept in-house.
Oh, thank you, Jeff. Really appreciate those kind words and really appreciate the work that we're doing together and look forward to hearing about the production system. So thank you, Jeff, AB, Ozan, for being here today and sharing your story with us.
Terrific, Sarah. Thank you so much.
Thank you so much, Sarah.
Thank you, Sarah, for hosting us.
You heard us mention our new prototyping lab in Santa Clara, California. Look out for an upcoming special episode where we'll take you inside to see how things are made. I'd like to thank our listeners for coming on today's journey with us. Innovation Ambassadors is a production of the AWS Media Series. Look for future episodes of our podcast on Apple Podcasts, Spotify, Stitcher, or your favorite streaming platform. If you have ideas for future episodes or comments on this one, send us a tweet at #AWS Innovation Ambassadors and share your thoughts. Thank you.